Is there a limit to how strong something can be? Science and industry's demand for strength is insatiable. And technological breakthroughs constantly push the envelope of what's considered the most powerful, creating new claims to the title of the world's strongest. Truckloads of junked cars and scrap metal are arriving at Sturgis Iron and Metal in Elkhart, Indiana. Powerful cranes unload the trucks, stacking the scrap into enormous piles. But the piles won't be there long. They're headed for the jaws of the heavy shredder, the largest and most powerful metal shredder in the world. Cranes feeding this metal-eating monster can barely keep up with its appetite for deconstruction. It can consume up to 480 cars an hour, 4 times the output of conventional shredders, reducing vehicles to fist-sized pieces of twisted scrap. The world's growing demand for recycled steel has created a need for this colossus.
Well, what we've got is an 8,000 horsepower, oversized paper shredder. And it's fed by a conveyor that's effectively a 200-foot long, 8-foot wide bulldozer track. Takes the car bodies up, they go down into the shredder, and like your mother's old wringer washer, there's a set of rollers that push the cars into the shredder. It is all shredded down to small pieces through grates in the bottom like an oversized cheese grater.
Inside the machine is a giant rotor that's mounted with 24 1,200-pound hammers, rotating at 450 revolutions per minute. The hammers slam into the scrap at 175 miles per hour, pulverizing entire cars into tiny pieces. Mike Woodward, who helped design this shredder, offers a look under the hood.
The shredder rotates in this direction, and the cars come down the feed chute right here, underneath the feed roller. And against the anvil, the spreader bar and the cutter bar, the hammers, which are whipped out with centrifugal force, come down and they strike the car, chopping it into small pieces. The machine itself, we've got 4-inch thick walls and 10-inch thick liners. There's just so much chaos and abuse in this machine. It has to take an unbelievable amount of pounding.
The shredder's rotating hammers receive nearly as much of a pounding as they deliver.
This hammer's been used once on this edge. You can compare it right here to this hammer that hasn't had this edge worn yet.
The sheer volume this shredding giant consumes is mind-numbing.
We're talking 6 to 8 cars a minute. So you can imagine the logistics, just getting that material to the shredder. The number of trucks that got to move, the number of crane operators that have to be doing their thing just right, getting them onto that in-feed conveyor, all stacked. It's a ballet, literally.
The choreographer is the machine operator, who oversees the workflow from a perch just above the mouth of the shredder.
We run everything, all the belts, in-feed, shredder, from right here in this area you see right here. My job is to control the material going into the shredder.
One hand control operates the belts feeding into the shredder. The other raises and lowers the feed rollers to accommodate pieces of different size. Computer screens allow him to monitor pumps, bearing pressures, rotor temperatures, or any delays that might have occurred downstream.
There's a lot of automation in the controls, but nothing can do as good a job as a man's eyes and hands for some of the oddballs that might be in the chute.
We are going to run a school bus here in a second.
Even a bus is no challenge for this behemoth. The feeder belt that pulls heavy loads up this steep incline produces a force equal to 5 D5 Caterpillar tractors. The shredder devours the school bus with ease, thanks to its 8,000 horsepower wound rotor electric motor. That's the equivalent of 4 locomotive engines. It runs on 4,160 volts and is fitted with a large liquid rheostat, which functions like a giant dimmer switch to prevent the motor from drawing too much current.
If it didn't have a liquid rheostat, if it stalled out, it could brown out the city.
Just as impressive as the size and power of this new shredding technology is the thoroughness of its recycling capacity. 400 tons of shredded scrap per hour move along conveyor belts where magnets extract the steel elements.
There's a series of inspectors who monitor the scrap as it goes by, and they look for things that shouldn't be there. Copper is a big one. Copper's bad for steel. It's the kind of thing that sunk the Titanic. If there's copper in your steel, it can make it brittle. When it comes out the end, we call it frag, and it's clean steel, ready for the steel mill to melt down and make new steel. All of the other material is what we call the fluff, or auto shredder residue. What we have here is the material that's been screened through about a 1 1/4 inch screen. It has no metals left in it. This is now what has to go to the landfill.
Sturgis Iron and Metal maintains its own railroad to deliver frag to the steel mill. But the heavy shredder has such an enormous output, sometimes it's hard to keep up.
Productivity of the machine is such that we actually run out of rail cars throughout the day. Sometimes they'll bring us 15, 20 cars. It's not enough for the day.
Being that productive takes a toll on the shredder, especially in areas of metal-on-metal contact. Daily service is required for the replaceable wear parts on the shredder's rotor.
Every night they have to change hammers like this, turn them around, and reorganize them for maximum productivity.
The introduction of high-efficiency, high-volume shredding giants will ultimately reduce the number of scrap metal processing facilities necessary for recycling purposes. But recycling on a scale like this comes with a price. Noise and vibration from the shredder affect the nearby community, creating tensions. The shredder's owners are involved in efforts to reduce the machine's impact on its neighbors. But the expression, "one man's trash is another man's treasure," has never been truer, as the world's hunger for secondhand steel increases.